All right, folks, we are here with example number 2 for multi-period production and inventory problems. If you remember, we did our pigskin problem, we did multiple periods with linking constraints, the whole deal. So now we'll look at a slightly more complex problem that has a few more moving pieces. Morton and Monson is a manufacturing firm that runs its workers in regular and overtime shifts. They wish to design a production schedule for January through April so that they can take volunteers early for those shifts. You have informed that at the end of April, they must have 300 units in stock. Okay? At the end of April, you must have 300 units in stock. We'll bold that. The cost of any units placed in inventory during a month is $40 per unit, and there is a minimum stock requirement of 100 units. So we actually have a minimum stock requirement of 100 units. Based on this cost and one worker working either overtime or regular time in the demand given in the following table, right over here to the left, design an LP to minimize the given costs. Hey, so we have our things, our inventory cost per unit, our minimum inventory, regular production cost, our overtime production cost, all these good things. Okay, we have all of our things, the production capacity, the overtime production capacity, and our given demand in any month. So we have to make some choices. Right? This is just like our previous problem. We have to choose how much to produce. But here we're going to have two kinds of production. So first, we need to decide on our regular production for each month. First choice that we have to make. Right? We will also have to choose our overtime production. I'm just going to drop this down here a little bit. So we get to choose our regular production and our overtime production capacity. Now we do know that we have a regular production capacity, right? So this needs to be less than or equal to. We can't exceed that capacity. And we'll go ahead and center that up. Okay. We also have our overtime production capacity. Oops, so let's cut that. We'll paste it down here. Same kind of thing, right? So let's fix up our formatting just a little. We can select all those cells at once by holding down the Command key. Give them all a nice border. There we go. So our regular production has to be less than or equal to our regular production capacity. Our overtime production has to be less than or equal to our overtime production capacity. Right? Makes sense? This should be all good. Okay. We have our total production, which is just the sum of the overtime production, how many we produced in overtime, and our regular time. Okay, so that is all good. And our total production has to, meet or beat our demand, I would think, right? So production, so let's move our demand down here and say production has to be greater than or equal to demand. That'll probably be true that whole way across. We'll go ahead and fix this up. So my total production will be greater than or equal to my demand. Now note, I'm only doing formulas for this first period while I'm working through everything here. We'll go in here and move this up so it looks a little more nice. And then we will have, we'll have some ending inventory. Inventory will just be my production minus my demand. Right? That's how much is left. But we do have this sort of weird constraint that this has to be greater than or equal to 100 units. So we are going to go ahead and we are going to point that back to this 100 units. We are going to lock it. We are going to hit enter. And we are going to drag it. I'm also going to use the format painter to just copy this down. So you'll see I click format and do that. If you're on Windows, I believe you have access to the format painter when you right click as well. Okay. This looks pretty good. Okay, so this is a fairly good, a fairly strong start. We've decided our regular and overtime production. We've set it up with limits. We've seen that our production has to be greater than or equal to our demand, and we have some ending inventory available, the amount we need and the amount required. So I think we're in pretty good shape. So let's go on to period 2, to February, and check out what this looks like. Well, in February, we are going to have regular production capacity. That's good. That has to be right? However much we use has to be less than the amount available. So less than or equal to 2,000. We're going to have some overtime that has to be less than or equal to 400. And then we're going to have total production, which is just the sum of this, right? It's exactly the same, actually, as our formula here. It's the sum. So that looks like it's going to be the same all the way across. We can live with that. But then, oh, this demand, right? How much do we actually have available? Well, what we actually have available to us is our production plus our ending inventory here. Okay, so we have two things to match. So I'm going to go ahead and I'm going to go insert this. And I am going to say total units available. In this month, that is just how much we produced because we have no initial inventory on hand. But in this month, it is my total production plus my ending inventory. My total production plus my ending inventory. And you'll see this will actually hold the whole way across. So if I have total production here, total production plus ending inventory, total production plus ending inventory. That's great. This does change things here though, because I've said, well, total production minus my demand, and really it should be total available at this point. You can see that very quickly because if I do this, well, going over here, all my numbers are going to be wrong because I'm only subtracting my demand from the amount available. So I'm going to move that down to the total available, work it all out. I'm going to stretch these here, okay? Reformat those so everything looks good. So you'll see we've had a little bit of intricacies in here that we've had to address, but I think we've taken care of all those. We then have our costs, right? We have required production costs. We have overtime production costs. We also have an inventory costs for every month. So we have a lot of costs going on here. Required production costs are very straightforward. It's our regular production times the regular production costs. Now I'm going to lock that so I can drag it all the way across for each month. Overtime is the same way. It's our overtime production times our overtime production cost. There we go. And we have our inventory cost, which is very much the same, right? It's our ending inventory times our inventory cost per unit. And we're going to lock that so we can drag it all the way across. Now that is an ugly number if you're in business, losing a lot of money on this initial model. But what we want to minimize is our total costs. So our total costs are just the sum of all these costs. Now you could do this a couple different ways, right? So I happen to go ahead and just sum them all up. Maybe that's not the best. Maybe you also want to add in a monthly total. Sum all these up, which you can easily do. And then we can even change this so that it just counts the sum of those. Okay? So the sum of all our months. And maybe you want this to be fancier, so you're going to put your total costs right here. It makes it, maybe it looks a little better, it flows a little better. So I think we're in good shape. We have a multi-period problem. We have implemented all our constraints, so let's give it a good save and go in and open up our solver. We want to focus on minimizing our total costs by changing these cells and those. Remember, you hold down the command key to do that. We have some constraints here. Our regular production has to be less than or equal to our regular production capacity. Our overtime production has to be less than or equal to our overtime production capacity. Our total available has to be greater than or equal to our total demand. And our ending inventory has to be greater than or equal to our required inventory on hand. I think we're in pretty good shape. We're going to make our unconstrained variables non-negative. We're going to go in and do the simplex method, and we are going to solve this and see what happens. So Solver does its magic. It is searching through potential solutions. Solver found a solution. This is an expensive solution. You'll see we have lots of values here. We are going to go ahead. Let's make this so that we can see what's going on and make sure everything is good. It looks like these constraints are all met, greater than or equal to. They are all exceeded. The man is exceeded quite well. We're producing lots in overtime. We're producing lots in regular production, right? Which is great. you'll see our ending inventory is greater than or equal to all of these, right? And we are in very, very good shape here. Now, I do think we did miss one thing. At the end of April, we missed something, right? 300 units in stock. So we need to change this value to 300. We forgot this one thing. So let's go back into our solver and let's resolve. Searching for solutions again. There we go, a different solution, right? Solver found a solution. It's a little different at this point because we had to make this, right? At the end of April, they must have 300 units in stock. So our whole production schedule shifts just a bit so that we are able to do that. And we are accommodating all the costs that we need to. So in short, we have minimized our cost. We have built a model to do the same, and you should be good to go.